Okay, so hopefully you were able to do that. So just as a quick little recap of the answers. So to find the range, all you do is you find the lowest score and the highest score. In this distribution, our low score is 1, our high score is 10. So to find the range, you just do 10 minus 1, and that gives you a range of 9. Same thing here, the low score is 11, the high score is 96. 96 minus 11 is 85. So hopefully that was pretty easy, kind of just, simple arithmetic. And, this is just a nice little quick way of capturing this sense of variability. But again, as we mentioned, this is kind of limited because, again, it kind of leaves off all of these numbers, the ones that aren't the two extreme ends. And so it's not super useful to us. We just basically use range as a descriptive statistic, and it doesn't necessarily help us as we go into more of the inferential kind of fancy statistics. So what's going to be a little bit more useful to us is something called the standard deviation. So the standard deviation basically is a way for us to represent the average distance from the mean. So if we take our data set, we look at all the numbers, we're going to see that there's a lot of variability from the mean. Each score is going to be a little bit different from the mean. And so when we use our standard deviation, we can actually compute an average of how different the scores are from the mean. So our standard deviation is going to be the most common and, for our purposes, the most important measure of variability. And what it's going to do is it's going to look at the distance or the deviation between the mean and each score in our data set. And we're going to be able to use this to measure variability. And this is going to tell us whether our scores are kind of clustered around the mean, where there's not a lot of deviation, there's not a lot of variability, or is it that they're widely scattered, that they're going to deviate from the mean quite a bit. They're very, very different from the mean. So with our standard deviation, the key thing to set this up is the idea of a deviation score. So the deviation score is simply a measure of how different each score is from the mean. So the formula is pretty simple. We just take a person's score and we subtract the mean from that score. And this is going to tell us two pieces of information. One thing it's going to tell us is a person's score above the mean or is it below the mean? And then secondly, it's going to tell us the degree to which it's above or below the mean. How close or far away is it from the mean? So just as an example, say we have a mean of 2. So as a quick reminder, this little symbol here is mu, and that's the symbol for the population mean. So we're just going to be using that in this case. So our mean is 2. Say we have a person who scores a 7. So our formula is simply the person's score, 7, minus the mean, 2. And what this will tell us is that we get a plus 5. And this means that, one, the score is above the mean. And secondly, it means that it is 5 points above the mean. So just as a quick illustration of what this looks like, say we have a little number line here and our mean is 2. So this little red line is representing the mean. We have a score of 7. And basically what this is saying is that it is 5 points above the mean. It deviates from the mean by 5 points. Here's another example. Say, again, we have this mean of 2, but in this case, we have a score of negative 2. Again, we plug it into our formula. Our score is negative 2 minus 2 gives us a negative 4. So in this case, this is telling us it's below the mean, and in particular, it's 4 points below the mean. Another example, say we have a score of 1. Again, we do the formula. The score of 1 minus 2 gives us a negative 1. And you can see here, first of all, it's below the mean. And we can see it's just a little bit below the mean, especially compared to, these two. Final one, say we have a score of 9. In this case, we're 7 points above the mean. So, this one's not deviating very much. This one's deviating quite a bit from the mean. And this is kind of what the whole concept of the standard deviation. So we're looking at, how different each score is from the mean. And what we're going to do is we're going to try to summarize all of these deviations. And we're going to look and say, basically, on average, if we look at our overall data set, on average, how much our score is deviating from the mean. Is it just a little bit? Is it a lot? And this will give us a sense of the variability of our data set. So that's our start. That's our base. So what we have to do now is we have to take those deviation scores that we found and calculate the mean. So here's an example of what this might look like with using some different numbers. So in this case, we have four little data points. Add those up, divided by 4, and we would get a mean of 6.25. Our next step is to find our deviation scores. So 9 minus 6.25, we see that we're 2.75 points above the mean. 8 minus 6.25 is 1.75 points above the mean. 5 minus the mean, this is 1.25 points below the mean. 3 minus the mean is negative 3.25 points below the mean. So we have our deviation scores. So now we have to find the mean of those deviation scores. So if we sum these all up, we would, if we were to do this the normal way, we would sum it all up and we would divide it by 4. But we kind of run into a problem. And the problem is that the mean kind of represents a balance point. So based on how the mean is calculated, basically these deviation scores are always going to equal 0. So no matter what our mean is, no matter what our number is, because we're using a formula to calculate the mean, basically half of the numbers are, if you sum up the numbers that are above the mean and you sum up the numbers below the mean, they're always going to cancel out. The mean deviation is always going to be 0. And that's a problem, obviously, because if we always get 0, no matter what our data set looks like, it's just straight up not informative. So we have to do a bit of a little trick to get around that. And that trick is to get rid of the negatives. And now there's 2 ways that we can do that. If we were in class, I would ask you. So if you want to take a little time to guess what that might be. One way that we could do it is we could take the absolute value. The other way we could do it is to square it, because a positive times a positive is a positive, and then a negative times a negative is a positive. So that's what we're going to do. We are going to square our values. And there's some reason that we're going to do this instead of just taking the absolute value. Both would be a way of getting rid of those negative signs. The benefit of doing the squaring is it kind of takes into a little bit more account that magnitude of the deviations. The closer you are to the mean, if you square it, the values aren't super high, but if you're very much deviated from the mean, when you square it, those values get quite a bit larger. So in a way, it kind of punishes a distribution for being really, really far away from the mean, and we get a better representation of how much the deviation is. So ultimately, what we're going to do is we are going to be squaring our deviations. So for instance, our deviation, a score of 9 was 2.75 points above the mean. If we square that, we get 7.57. Same thing for, this 1.25. For our 5, we were negative 1.25. When we square that, a negative times a negative ends up being a positive. So we get 1.56. Same thing for this one, we get 10.56. So you can kind of see in a way here that the whole idea of squaring kind of emphasizing the larger deviations. This one is somewhat close to the mean. It's only 1.25 below the mean, and if you square it, it doesn't really super change that much. It gets a little bit higher, but not crazy. Whereas this one that's negative 3.25 points below the mean, when you square that, it gets up to 10. So basically, understanding that we might have some outliers in our, or more extreme scores in our distribution, and when we square that, it emphasizes that more. So if we were to sum up this, we would always get 0 no matter what. But when we square up our squared deviation scores, we'll actually get a number that we can work with. So this concept, this summing of these deviation scores squared, is something called the sum of squares. So this is a term that's going to be popping up throughout the semester, this idea of the sum of squares. And you'll see it abbreviated oftentimes as SS. And basically what it is it's a sum of the deviations squared. So this is basically what we just did. You find the deviation score, you square it, and then you add up all of these, and that will give you the sum of squares. So that's the kind of basis of this representation of how different the population is. The scores are from the mean. I'm getting ahead of myself. So one issue with the sum of squares, though, is that it's the sum of the squares, the deviation squared. So the more data points that you have in the data set, the larger this number is going to be. It doesn't necessarily matter the actual variability in the data set, but anytime you add a number, so if we just added 2 here, even if it was kind of close to the mean, it would just add on to the sum of squares. So it's not really interpretable on its own. You can't really make any sense of it because there's like too many factors that go into it. So what we have to do is kind of standardize it in a way. That's why we call it the standard deviation. So we have our sum of squares. Now what we're going to do is we are going to basically divide it by the number of data points that we have. So that kind of takes into account that idea that the more numbers we have, the higher this number goes. This is kind of a way to get at what's the average deviation. Now we're going to take a stop on the way before we get to the standard deviation. What we get when we divide by the number is actually something called the variance. So the variance is usually represented by this symbol. This is lowercase sigma, sigma squared. You can just say it as, this is the variance. But this is basically going to be a representation. It's the average squared deviation or distance from the mean. So all it is you find your sum of squares and you divide by the total number of data points. So here we have 4 data points. Our sum of squares we found by taking the deviations and squaring it and summing it up is 22.75. So we just take that, we divide it by 4, and we get a variance of 9.69. No, I'm still wrong. 5.69. Numbers are hard. So that is going to be your variance. And that's a tiny bit more interpretable than just the simple sum of squares. Now, the variance is useful, and we will actually be using the variance in some of our statistics, but it's still honestly a little bit hard to interpret. And the reason for that is because, we kind of transformed the simple deviation, which is fairly easy to understand, into a squared value in order to get rid of those negatives. So what we're going to have to do now is we're going to take the variance and we're going to kind of transform it back into something that's a little bit more understandable. So since we squared it to get into our sum of squares and our variance, to go back into just those simple deviations, we take the square root to kind of cancel out the squared. So the standard deviation, the relationship between the standard deviation and the variance is they're basically the same thing. The only difference is that the standard deviation is the square root of the variance. So it's kind of, taking away that squaring procedure that we did and making it more interpretable. And what it gives us is basically it measures that average distance, the average deviation from the mean. So standard deviation formula is simply the square root of the variance. So putting it all together, our variance, or that sigma squared, it's the sum of the deviations squared divided by n. and then the standard deviation is just the square root of that. So you can either just plug that in, or you can use the overall formula, just the square root of our sum of squares divided by n. So if we were to do that, our standard deviation is 2.39. And so ultimately what this is telling us, if we go back to our little data set, is that on average, our scores are deviating from the mean by approximately the 2.39 points. So that gives us a little sense of how different each score is from the mean. And we can use this in our future statistics to compare different distributions, and to think about, whether scores truly are very different from the mean. All right, so hopefully that is, I know that's a lot of math. We'll kind of come back and do some summary and, some of the big ideas in understanding standard deviation and variance. But before we do that, I just want to give you a chance to do a little bit of a practice. So we're going to wrap up this little section of the lecture, give you a chance to do a little practice quiz. What I'd like you to do is for the following little data set, these 5 data points, what I'd like you to do is you can use this table to fill this in, but what I'd like you to do is find the sum of squares, that sum of the deviation scores, find the variance, so your sum of squares divided by n, and then find your standard deviation, which is just the square root of that variance. So go ahead and do the little practice quiz, and I will meet you again in the next set of slides.